So we have the first name is 5-methyl heptene. Now, the first thing you do when you're going to draw the structure is look for the longest chain part. Okay, and this part here is my longest chain. And so I can see that with the hept. How many carbons is that? 7. So I'm going to just 1, 2, 3, 4, 5, 6, 7. So I'm just going to draw out my chain of 7. I looked to make sure there was no cyclo there, so I know it's a straight chain. Then the next thing I'm going to look at is the fact that it's got a double bond. Okay, so double bond on the second carbon in the chain. So I'm going to come along and I'm going to number. Doesn't matter which end I number from, because at the moment they're both the same. And so this tells me the double bond is on the second carbon. So I can put that in there. And for this particular one, now I'm going to look to see what other things are added, and these are always at the front. So I've got 5-methyl there. Tells me I come along to my 5th carbon in the chain, and I'm going to put a methyl group on it. And when we're putting a methyl group on, and even though we're asked to for full structural, I can sort of shorten the group just down to CH3, just the same as it's written on your formula sheet. And of course this is not finished because what's missing? The hydrogens. So so that's our last step. Okay, so now I'm just going to come around and put hydrogens on so that every carbon has 4 bonds. Be careful with the double bond here. You know, like you can sort of get into a bit of a rhythm where you're putting them up and down, but then that would be too many. Okay, and now that should look pretty similar to the one we have in our booklets. And so if we look at the next example, which was 4-ethyl, 4-methyl octarine. Let's do that same process. So what's our first step? One longest chain, which is going to be what? The oct part. How many carbons will there be if it's oct? 8. 1, 2, 3, 4, 5, 6, 7, 8. What are we going to do next?
Your double bond.
A double bond. Where's the double bond going to go? On 2? How are we going to know which one's the second carbon?
Depends on which end you count from.
Yep, so we just have to number from an end. Yep. So how about we stick it here? What's our next step?
The add-ons.
Yeah, add-ons, anything out the front, out. And where is that going to go? On the 4th carbon. Now, because we've put our double bond here, we have to keep going with that numbering. So once something's put in, that's it. You can't change your mind and start putting things in from the opposite direction. 1, 2, 3, 4 has to be on this one. You don't need to memorise methyl and ethyl and everything because they're also on your formula sheets to remind you what to write there. Now what's next?
Or are we just on that?
Yeah, we need to put the methyl on as well. And what's next?
Adding
Okay, we just have to be able to count 4. Yeah.
Just a quick question about the ethyl. On our formula sheet, it just says C2H5. So if we just put C2H5, would that count the same as CH2CH3?
Yeah, yes, it would. But look, I guess I prefer this way because that's not wrong. But if you're asked to do structural, we really should be like this is called semi-structural, whereas that's more molecular, and so I think you're more likely to be able to, like, you'll get away with this, but it would depend on the marker with that one, and I would hate to tell you something that then someone decides to penalise.
If we are asked to do the full structural, is it better to just like draw
All
like
bonds.
the whole thing?
It just depends on how much room you've got.
Yeah.
So if because you write fairly small, you can probably fit all the bonds in. But some people who write big are going to struggle to get the structure in. And so it's a trade-off there. Because you want it to be clear and easy to read. And so if doing it this way makes it clearer and easier to read, then I would definitely do it this way, rather than drawing out all the bonds where it ends up being hard to see what you've done. You know, sometimes they curl around the question and go up the page and things like that. So that makes it harder to see what someone's done. Okay, and so our last thing that we needed to do was to go around and make sure every carbon had 4 bonds. So like I said, be careful and count to 4. Because a very common error is for a carbon to end up with 5 bonds. If you're not sure, you know, like if I drew a circle around this carbon, for example, then I can see how many bonds it's got. I can see what's in there. If everything else is distracting me, I can do that. But you just make sure that you everyone needs to have those hydrogens put on there. So does this process look like it is making sense? Let's do example 3. And this is 2,2,3 trimethyl butane. Okay, so what's step 1? Longest chain, which is going to be the but. How many carbons? 4. 1, 2, 3, 4. Okay, what's our next step? It's an ane, so what does that tell me? Single bonds. So I don't need to look anymore in the chain here. I'm going to be looking at the front information, aren't I? So what's next?
Adding the methyls. Well, you're going to have 2 methyls on the second carbon and 1 methyl on the third.
Yeah. So we want to number the chain to do that. And even though you can look at this, because it's so short and you didn't think you needed to number, with the bigger molecules it's going to be important that you do number so that you keep a track of where everything is going. Yep, and so that means that we've got a methyl here, a methyl here, a methyl here. And what's our next step then? Add the hydrogens. That's right. Okay. I want to just, I know, did you do any tricky ones with Rob? I might save that up for Tuesday next week actually. I'll try and do some tricky naming for you. But yeah, so have a go at the next lot of questions with the drawing. So question 11. This is page 56. That's where you're up to.